Hello, this is your review for your radicals and radical function test, which will be on Wednesday, February 17th. The first part says rewrite the following in radical form. Do not try to find an answer. So here you just need to write this with the radicand, the radical symbol or root symbol, and the bottom number of your fractional exponent is what the root is. So the root on this one is the cubed root of 2x plus 7 to the fifth. And now the 5 can be written on the outside like this, or it can also be written as 2x plus 7 to the fifth like this, either place. And B, same thing, the ninth root of 18 to the seventh. And C, now on C you have a negative exponent. Anytime you have a negative exponent, you're going to do the reciprocal. So it's going to be 1 over the fourth root of 4x minus 3 cubed. Then on number 2, you're kind of doing the opposite of this, all right? So your first one, you've got the square root of 2x minus 5. Anytime it doesn't have a number outside, it's assumed to be a 2 on your root. So this would be 2x minus 5 to the 1 is your power, and then 2 is your root. On B, this would be 2x minus 7 to the 3 is the power, 5 is your root. And on C, you have a reciprocal, so we know it's going to be a negative exponent. So this is going to be 2x minus 7 to the negative, power is 4, root is 7. Number 3 wants you to evaluate. Use these exponent rules to evaluate these. So 25 to the 3 over 2 is the same as the square root of 25 cubed. And we all know that the square root of 25 is 5, and 5 cubed, 5 times 5 times 5 is 125. B, you have 36 to the negative 1/2. So again, the negative means that we're going to do 1 over 36 to the 1/2, or the 1 over the square root of 36. And the square root of 36 is 6, so 1 over 6 is our answer. C has 8 to the 4/3, so that's going to be the cubed root of 8 to the 4th. The cubed root of 8 is 2. That's a number that multiplied by itself 3 times would give you 8. And 2 to the 4th. 2 times 2 times 2 times 2 is going to be 16. D has 1/8 raised to the negative 2/3. So the negative means that I'm going to take the reciprocal. So that would be the same as 8 to the 2/3, or the cubed root of 8 squared. Cubed root of 8 is 2, 2 squared is 4. On the following page, we have a graphing example. So on number 4, it says for this question, let g of x equal 4, square root of x minus 3, outside the radicand is minus 8. We want to find the domain. Remember, the domain is the possible x values. So the x values that I could put into this. Well, I know that I can't take the square root of a negative number. So x minus 3 has to be greater than or equal to 0. So then x is going to have to be greater than or equal to 3. So if you want, this would be in set notation, would be just like that. If you wanted to use interval notation, you'd have bracket 3 to infinity. And then if you want to find the range, well, I think the range is a little bit easier to look at from the graph, but if we think about this as far as transformation, the minus 3 moves this graph to the right 3, the minus 8 moves it down 8. So our square root parent function has an endpoint at 0, 0, and looks something like this. Well, if this were moved down 8 units, now the bottom of it would be at negative 8. So y would have to be greater than or equal to negative 8, or if using interval notation, from negative 8 to infinity. C wants to solve when g of x is equal to 12. So that's just saying that 12 is equal to 4 times the square root of x minus 3 minus 8. My first step in solving radical equations is to get the radical by itself. So I'm going to start off by adding 8 to both sides. And that gives me 20 is equal to 4 times the square root of x minus 3. Then I'm going to divide by 4. So I get 5 is equal to the square root of x minus 3. Now that I've got the radical sign by itself, I can square both sides to get rid of it. So that gives me 25 is equal to x minus 3. Now I'm going to add 3 to both sides, and I can see that x is equal to 28. So that is the x value that would give me out a y value of 12. It's important with radical equations to always check these answers, okay? So I check it by just substituting in this value for x. So 4 times the square root of 28 minus 3 minus 8. 4 times the square root of 28 minus 3, that is the square root of 25 minus 8. Square root of 25 is 5. 4 times 5 is 20. Minus 8 is 12. So this works. Find the coordinates for the x-intercept of g of x. And I know that my x-intercept occurs when the y value is 0. So I can solve this problem D similar to how I solve C. I can set my equation, my function equal to 0. So 0 is equal to 4 times the square root of x minus 3 minus 8. Move my 8 to the other side. I have 8 is equal to 4 times the square root of x minus 3. Divide both sides by 4. 2 is equal to the square root of x minus 3. Now I have my radical by itself, so I'm going to square both sides. Gives me 4 is equal to x minus 3. Add 3 to both sides. X is equal to 7. Again, want to check these because I will get extraneous solutions sometimes. Those are solutions that you've done all the algebra part right, but they still don't work in the equation. So 4 times the square root of 7 minus 3 minus 8. 4 times the square root of 4 minus 8. Square root of 4 is 2, so 4 times 2, which is 8, minus 8 gives me 0. So that is my x-intercept. And I would write that x-intercept as a coordinate point, so 7, 0. Now I need to graph my function. So I'm going to use transformations to graph it. The 4 outside of my function is going to be a vertical stretch of 4. The minus 3 on the inside moves my graph right 3, and the minus 8 is going to move it down 8. So to graph my endpoint, I'd go right 3 and down 8. And now the vertical stretch of 4 means that normally when I take the square root of a number, if I took the square root of 1, the square root of 1 is 1. So I'd normally, from my origin, I'd go over 1 and up 1 to put a point. But that vertical stretch is going to multiply my y values by 4. So from my endpoint, I'd go over 1 and up 4. Alright. My next point that I know from this endpoint is that I normally go over 4 and up 2 because the square root of 4 is 2. However, this time I'm going to go over 4 and up 8 because my y value would be 2 times 4. My vertical stretch is 8. Incidentally, this is that point at 7, 0 that we found. So that is another way you can always find your points, is once you found your endpoint at 3, negative 8, you could plug in values for 4, and that would have given you negative 4, and we plugged in 7, you would get out a y value of 0. If you sketch this, get something that looks like that. Flip over. Now we have some solving radical equations and one with rational exponents. So on A, we have the cube root of 2x minus 1 is equal to 5. I want to get rid of my cubed root, so I'm going to cube both sides, so that gives me 2x minus 1 is equal to 125. Then I would add 1 to both sides, so 2x is equal to 126. Divide by 2, and x is equal to 63. And always plug this back in to solve it. 2 times 63 is 126, minus 1 is 125. The cubed root of 125 is 5. B, 4x plus 1 is equal to 4 over 3, or sorry, to the 4 over 3 is equal to 81. Here you would want to raise both sides to the reciprocal power, so that'd be 3 over 4. So 4x minus 1 or plus 1 is equal to 81 to the 3 over 4. Or you could write it the fourth root of 81 cubed. So the fourth root of 81 is 3, and 3 cubed is 27. Now we have an equation we can work with. 4x plus 1 is equal to 27. I'd subtract 1 from both sides. So 4x is equal to 26, and divide by 4. X is equal to, 4 goes into 26, 6.5 times. Find the domain of the square root of 4 minus x squared. So I want to know when that 4 minus x squared is greater than or equal to 0. And to solve that, I would subtract 4 from both sides. So negative x squared is greater than or equal to negative 4. So then I divide it by negative 1. Say x squared is less than or equal to 2. And take the square, or sorry, x squared is less than or equal to 4. Got ahead of myself. Take the square root. X is less than or equal to 2. And the absolute value of x is less than or equal to 2, because I know that this can be the square root of x squared is equal to the absolute value of x from back when we studied absolute values. So x can be any value from negative 2 to 2. So you'd write this like an inequality sandwich. Negative 2 is less than or equal to x, which is less than or equal to 2. If we think about the range for this function, those are the y values that we're going to get out. Well, we know that it's going to, it hasn't been moved up or down. We don't have anything there, so it's going to start at 0. And it would go, if x were 0, it would be at its highest point. 4 minus 0 is 4. The square root of 4 is 2. So it'd go from 0 to 2. That is in interval notation. If you'd written A in interval notation, be from negative 2 to 2. So this will look like a semicircle. Number 3, write a radical function with a domain from 3 to infinity and a range from negative infinity to negative 3 and a vertical stretch of 2. So our radical function is going to be f of x is equal to some value a square root of x minus h plus k. Now I know my domain is when 3 is from 3 to infinity, so that means that it's been moved right 3. And I know my range is from negative infinity to negative 3, so I know it's been moved down 3, but also if it goes from negative 3 infinity to negative 3, it's had an x-axis reflection. And I have this vertical stretch of 2. So when I go to write my function, I'm going to have f of x is equal to negative, because of my x-axis reflection, 2 square root of, to move it right 3, I'd have x minus 3, and then to move it down 3, I'd have a minus 3 at the end. Number 4, write a radical function with a domain from 7 to infinity, a range from negative 5 to infinity, and a vertical shrink factor of 2/3. Alright, so this domain of 7, I know that it's been moved right 7. The range is from -5 to infinity this time, so it means it's going up, so it has not had an x-axis reflection, but it has been moved down 5, and a shrink factor of 2/3. So that would be f of x is equal to 2/3 the square root of x minus 7, and then outside of this minus 5. Number 5, solve for x if the cubed root of x plus 4 minus 1 is equal to 5. My first step in solving radical equations is to get the radical by itself, so I'm going to add 1 to both sides. That gives me the cubed root. 3 times the cubed root of x plus 4 is equal to 6. Then I would divide by 3. So the cubed root of x plus 4 is equal to 2. Now I'm going to cube both sides. X plus 4 is equal to 8. Subtract 4, x is equal to 4. If I plug that back inside of this, 4 plus 4 is 8. The cubed root of 8 is 2. 2 times 3 is 6. Minus 1 is 5, so that checks. That is your review. Your test will be this Wednesday, February 17th.